So guys, am I audible? Just write yes. Do I think I'm audible? Okay. So this was the first problem of the contest, A buttons. And in this problem, it says that Anna and Katie ended up in a secret laboratory. So there are like A plus B plus C buttons in the laboratory. And it turned out that A buttons can be pressed by Anna, B buttons can be pressed by Katie, and C buttons can be pressed by both of them. And they decided to play a game such that they will be taking turns, and one by one they will press the buttons. Obviously, they can press only some buttons, and at some point of time when someone is unable to like press a button, in that case that guy will lose. And it has also been mentioned that every button can be pressed only once. So let us see what we can do. We have been mentioned that there are A buttons that can be pressed by, let's say, A guy. We don't really care about the name. And there are B buttons which can be pressed by only by guy B. And C buttons can be pressed by both of them. And both of them are playing a game in which they have to press a button, and they like the one who is not able to press any button will lose. So obviously that all of them will be willing to press the button which both of them can press. Otherwise, if they like the guy A presses a button A and the other guy always press the button C, at the end what will happen is that C buttons will be like the count of C buttons will be zero, and now all the B buttons which are remaining can only be pressed by the guy B. So it's obvious that both of them will try to press only the button C in the start. So we can say that the count of A, like the guy A will be able to press the number of buttons which the guy A will be able to press. Let's denote it by NOA. It will be equal to A. These are the buttons which he can press at any time, plus the upper bound, like the upper division, or maybe we can call as the seal division of C by 2. And in case of the guy B, it will be just B plus floor division of C by 2. And now you can just directly compare like NOA and NOB. If NOA is greater than NOB, if NOA is greater than NOB, in that case you can directly say that A will win. And if it is like less or equal, in that case A will lose. Okay, so this is one of the implementations. This is one of the ways of approaching the problem, and I think that this is the best. Not be taking long in the question as. Yeah, you can. Here, long is not required, but you can take, though it's not required. It will work even without long here, because the range of integer is 2e9. Okay, so there is one more implementation which I did. So the implementation was that we can just find if C is odd or even. If C is even, in that case, it means that like when both of them are, what will happen? What if we start from A and B first? Uh, we will start from A. Like always, we will start from A first. Now like the other approach which I'm going to tell about now is that we are always gonna be pressing the button C. Both of them will press the button C first. So if C is like I don't really care about the value of C. I just care about whether it is odd or even. So if the value of C is even, in that case, what will happen is, let's say if the value of C is 8, what will happen is that both of them will keep pressing it one by one, and at the end it will become 0. And it will be A's turn at that time. And in case if it was something like 9, so what will happen is that both of them will keep pressing it until it become 1. Then A will press it for this 1, and it will become 0, and now it's gonna be B's turn. So it is something like just changing the turn. To say that we don't click C first. No, we will always click the C first because we have to go for the most optimal approach and the perspective of A and B. Okay, so now let's see that um, once we have taken care of this, we will get to know whether it's gonna be A's turn or B's turn. Now let's say if it is A's turn, in case of C was even. So now the value of A should be greater than B, only then A will win. If it is less than or equal to B, in that case, B will win. And in case if it is B's turn first, then it's just gonna be reversed like here. So I think that it is pretty easy to implement now. And let's look at the code part. So what I did was, first of all, I took the inputs and then I said I created a variable with name C with a variable name turn, in which I just did put whether C is odd or even to know about whose turn it is gonna be. And here I just made one thing clear, that if A is greater than B, then no matter what happens, A will win. If A is less than B, then no matter what happens, B will win. The only change, like turn depends only when it is about both of them are equal. In that case, it matters. Like this thing is not required here. You can just remove it safely. During the contest, I wrote some extra code, but it's not really required. Even this part can be written like C mod, like C and A. During the contest, I wrote some extra code, but it's not required here. So we can just simply check if it is gonna be A's turn and both of them are having the equal number of buttons which only they can press. In that case, the other guy will win. So if it is A's turn, then B will win. And if it is B's turn, then A will win. So is anyone having any problem with this problem? Like, is there anybody having any doubt? Most of people submit A in 2-3 minutes. I generally read and understand the problem in 3 minutes. Um, Someone is asking that generally people solve the A problem in 2-3 minutes and he actually spends 3-4 minutes in reading it. So it's completely okay. It like as when you are the beginner, it doesn't really matter. But as you keep improving yourself, so you will be more comfortable in reading the problems faster as well, at least till some extent. You will read half of the problem and you will get idea of the other half, and like you will just skip a few lines in between as well. As of now, you don't really need to worry about it. Please explain the second equation again. Okay, so in the second approach, I just said that if A is greater than B, then always this guy will win. You can try to prove it yourself. This is having a very simple proof. And in case if A is less than B, then the second guy will always win, no matter whatever the value of C be. And in case if A and B, both of them are equal, then I care about whose turn it is gonna be first to press up his button, like at the end of the time when they are just pressing the button C. So I just checked it that if it is gonna be A's turn, then B will win. And if it is gonna be B's one first, then A will win. So I think that now everyone will be happy with it. So, okay, almost everyone is happy. How many problems to solve when not able to contest to become a specialist? For becoming a specialist, you need to be always able to solve the first two problems and sometimes being able to solve the third problem also, depending upon the difficulty of the problems. So let's move on to the second problem. For becoming masters, you generally need to solve the first four problems quickly and sometimes even the first five problems. Okay, so the second problem was a little bit complicated or maybe a little bit complex. So we will come to it after the third problem. The third problem was comparatively easy and it was observation based. So in the third problem, it says that Alex got a new game called GCT permutation and like some random stuff. And then we have been told that there is a permutation of the first n natural numbers, and in each I from 1 to n, an integer di is equal to the GCD of two consecutive elements. And in case if I is the last element, then the first and the last element. We will discuss this again. It's calculated, and the score of the round is the number of distinct numbers among the d1 to dn, and then some random stuff which you can read obviously. So our motive is to find this the sum of this our motive is to find the score to be maximum. We want this score to be as large as possible. So let's see. First of all, let's see how is the score defined, and then we will come to the logic part. So let's say that there is a permutation. Let me just take up any of them. Let's say let's take this permutation 1 2 3 4 8. Okay. Um, 1 2 3 4 8 5. 1 2 3 4 8 5 10 6 9 7. 10 uh, 6 9 7. So here D1 is gonna be the GCD of first two elements, which is 1. D2 is gonna be the GCD of next two elements, which is again 1. And D3 the GCD of next two elements, again 1. The GCD of next two elements, here it is 4. The GCD of next two elements, again it is 1. The GCD of next two elements, it is 5 now. The GCD of next two elements, this is 2. The GCD here, it is 3. The GCD here, it is 1. And the GCD of the first and the last element, which is also 1 here in this case. So this is how we will find the D1 to Dn. And now the score is gonna be the number of the distinct elements here. So what are the distinct elements which you have here? One of them is 1, then 2, 3, 4, and 5. Fine. So in the contest, what happened was that as soon as I observed this thing that they are just 1 to 5, I tried to think that will I always be able to, like, the value of n was 10 and this were from 1 to n by 2. So I tried to think that can I always have n by 2 distinct d's here? And apparently it was easy. Not yeah. So how to get it? The idea was that first of all I will take like 1, any number you can take. Then the next number is gonna be its double. Let's talk about it very intuitively. So if I want, first of all, let's discuss that why I can never get a score greater than n by 2. So let's say I want to get a score which is for n, I want to get a score which is something like 6, which is greater than n by 2. So it means that I will be like 1, 2, 3, 4, 5. Even these are just 5 elements. So I must be having at least one of the elements 6, 7, 8, 9, or 10. Among these elements, at least one of them must be the GCD of two consecutive elements. But it like you can see that if you want to have two elements having a GCD of 6, it means that there should be two distinct elements which are multiples of 6. And it is not possible here because the maximum element is 10. So if you try to have any element greater than n by 2, you will always come up to this contradiction that you cannot have it. So our assumption was wrong. The assumption we made to have like 6 distinct Ds here. Now let's see, can I guarantee that I will always be able to form these elements as the GCDs of two consecutive elements? So yes, I can do this. How? I will say that if I am having 1 as the first element, and let's say I pick up 2 as the second element. If I want to have 2 as the GCD of two consecutive elements, I can always have it by taking any element which is a multiple of this. So let's say I took 4 here. Now, can I have GCD 4 as the GCD of two consecutive elements? Definitely I can have, because 8 is also present, which is a multiple of 4. So I just again took a double element, an element which is double of this. Can I have 8 as the GCD? I cannot have it, because any multiple of 8 other than 8, like the smallest multiple of 8, which is greater than 8, is going to be 16, which is not inside the range. So you cannot go further. So what to do now? Obviously, you're not able to have 8 as the GCD, and you have taken these three elements as the GCD. Now try to move on to some other element. So what I said was that, let's say I'm having these 4, 5, 6, 7, 8, 9, 10 elements. These elements which I will be printing or will be having a permutation of. I have used 1, 2, 4, and 8. 1, 2, 4, and 8 have been used. Now the next smallest element is 3. So let's print it. I printed 3. It is having a GCD. 8 and 3 are having a GCD of 1, which is of no use for me. I have taken this as well, by the way. So someone is having his microphone on. Can you please turn it off? Otherwise, I would have to remove you. Okay, so let's come back to the approach. I have 10, 1, 2, and 4 as the GCDs. Now I want to have 3 as the GCD. So I can just directly like pick up an element which is a multiple of 3, which is 6 here. Because I'm just going in the approach that I don't know, like if I want to have x which is less than or equal to n by 2 as the GCD, I don't know if 3x, 4x, or any number is present or not inside the array, inside the permutation range. But I know that 2x is definitely gonna be present. So I can just have 2x as the next element. So here I got 3 as the GCD. Now I can like see that 6 is not possible to become a GCD. Come up to the next element which I have not used, 5. Let's say I come up to 5. Do I have that like 2 into 5 in the um, set? Yeah, I have. So let's use it. So I've used 5 and 10. And here the GCD is 5. Yeah, I will prove it once again if you want. Okay. So now when I have used 10, I know that twice of 10 is not present here. So we will come up to the next element, which is unused till now, which is 7 here. So let's come to 7. And there the GCD is 1, which is already used. And actually, I have already found all the GCDs, so I don't even need to worry about it. And someone asked in the chat that if I can again prove that I will never have more than n by 2 distinct Ds. So here the D was not again proved.
Actually, he asked that he has to repeat the part after this. Like, he told no.
Okay, after the proof.
Yeah, yeah.
Okay. So like in the proof, I told you that it is never possible. We determined till now. And then I try to think, can I always have n by 2? Like, can I think of a way in which I will be able to say that I will always be able to have n by 2 distinct T's? So I realized that if I pick up any number x, which is less than or equal to n by 2, I can pick up 2x as its next element. So here, let's say that I am having 2, then I can pick up 4, which is that twice of that element as the next element, so that the GCD will be 2 here. And like I started with 1, you can start with any number. I think without 1 also it will be working. But like obviously you are willing to do it in a contest as a and having a good approach. So you just started with 1, which is the safest one. And then you wanted to have 4, like this 4 is your x now. So you want to have its double, which is present. So you took 8, and again a GCD is formed. Then twice of 8 is not available, so you went with 3. Twice of 3 is available, so you wrote it down. Twice of 6 is not available, so you came up with 5 now. And then it's twice, then 7, and in this way. Okay, so is anyone having any doubt in this problem, in the C problem? If the approach is clear, then we can go to the code part. Okay. Effectively, we just found out the pattern. Yeah. This is like a constructive algorithm problem uh, in which you have to find some patterns. You have to find some patterns. So here we came up like not just a random pattern. We actually came up with some intuition that if we find x which is less than equal to n by 2, then you can have it something like this. This is not actually any algorithm. You have to construct it. You have to design it on the go in the during the contest. So let's see the code. In the code, I first took the inputs. Sorry, this is not the code. Yeah. So at first I took the inputs, which is just an n, and then I declared a set of integers, which is obviously not necessary. You can declare an array of size and also it's completely up to you. I just declared set because there was like the constraints were not tight. And then I printed one again, like the code can be written even better that you can write it like this also. But just for the for being on the safer side, I wrote it like that, but it will also work. And what I'm doing is that for every number from 1 to n, I'm just checking if it is inside the set or not. If it is not inside the set, then I will just go up to the next element. If it is inside the set, then I will go into a loop where I will be printing it first, like printing it and checking for like trying to print the number which is just the twice of this element. And again, this is also not required here. Um, this is also not required. I just wrote some extra code during the contest because I wanted to be on the safer side. That even if I make some minor mistakes somewhere, so I might be lucky enough to have like pass all the test cases because of writing some extra code. And it's obviously not required. So we are just checking if the element is inside the set or not. If it is not inside the set, it means that it has already been picked. Otherwise, we will pick it and all the elements which are double of them until we don't have any other choice left. And at the end, we will just print this endl. And so like, is this approach clear to you all?
Yeah, hello.
Yes.
I have a question. Can we do it like this? That let's say that I want one as in my answer. Okay, ठीक है?
Okay.
So we can do one and two, right? It's a pair.
I didn't get it.
मान लो कि हमें चाहिए आंसर में किसी का आंसर आ रहा है एज अ वन आ रही है, ठीक है,
Hmm.
वैल्यू GCD की, फॉर एग्जांपल लेट्स से 1 and 2. ओके,
Okay.
सो आफ्टर दैट वी कैन लेट्स से नाउ वी वांट आंसर एज 2, ठीक है, तो 2 के लिए हमारे पास ऑप्शंस क्या हैं, 2 and 4 ये हो सकता है एक
Yes.
पेयर,
Yes.
फॉर 3 आई एंड वी कैन डू आल्सो लाइक 3 के लिए 3 and 6 ये पेयर बन सकता है.
Yes.
So I was
Yes.
thinking that we can use a map of pair, or sorry, only single map.
It will just become complicated, I think. Like at the end, you will be doing the same stuff to have it simple.
So
Uh, like if you want to discuss just your approach, then we can discuss it after the session
okay,
because
okay.
there are many people here. The approach which you were telling was actually not making it simple, but making it complicated. So let's have it like this. So is this clear to everyone? Okay, about the time complexity part. So this loop is going in big O of n, right? This loop is going in big O of n. And if you see, this loop is going for like twice again and again. So it is something like log of n, something like this. So it's big O of n log n. It can be said like this, but it will be even better than that because we are not going for log n for every element. So like this is something like even better than n log n, and you don't really need to worry a lot about that. In case if the constraints are very tight, then we will be actually calculating the whole thing, that how many times will it go on, like we do in Sieve. So I think it will be either n
Excuse
log
me.
n. Yes.
What if I use unordered map in case of set? What will be the time complexity there?
Okay. So if you use the unordered map, um, like the only difference is gonna be that here we were using this n log n for inserting, and this log n for erasing. That thing will be saved. So there is log n also. There's one log n more. So this is n square log n log square n. If you use the unordered map, then this complexity will be done in big of 1. Okay, so can we move to the next problem? Just write cool inside the chat if you till here. Okay. Yeah, so let's come back to the second problem, the B problem. Okay, so now let's come to the B problem. In this B problem, we have like I will be explaining the problem statement also, because I think that many people might have been stuck here. There are n benches near the main wall, like walkway of some random stuff which is not important. And then these benches are being named from 1 to n in order they follow. And there are m cookie sellers near the walkway. The ith cookie seller is located at SIth bench. Okay. So it is like there is a pathway where there are a lot of benches with named like 1, 2, 3, 4, 5, till like so on till n. And there are many cookie sellers in between. So let's say there is a cookie seller here at the point 3, a cookie seller here, a cookie seller here, a cookie seller here. So there are many cookie sellers near the benches, and they have been mentioned to us. Now it is saying that is standing at the beginning of the walkway. So Petya is at the 1 position or at the 0 at any place. He will pass near all the benches starting from the first bench and ending at the nth bench. Petya passes the distance between two consecutive benches in 1 minute. And he has a knapsack with an infinite amount of cookies and like again some random stuff not required. Petya eats cookies only near the benches, and someone's mic is on. Okay, so let's come back. So it is telling that he will eat cookies near the ith bench if and only if there is at least one of the following conditions which holds. So in the first condition, it says that the cookie seller near the ith bench, so it like when he comes to the third bench, he will eat he will eat a cookie, and after eating, like he will eat the cookie and buy it. So again, some random stuff not required for the problem. Peta has not eaten a cookie. So if Peta has not eaten any cookie, then he will take a cookie from the knapsack, a knapsack, and eat it immediately. So it will happen for the first case. Like when he will come at this place, since he has not eaten any cookie, he will eat it here. He will eat it here. And the third case, that at least D minutes have passed since he ate for the last time. So let's say he ate at this place and the value of D is 2. So when he will come to this bench, he will feel like there has been 2 minutes since he has not eaten any cookie, and he will eat a cookie here. So he will eat a cookie here. So these are the three places where he is going to eat the cookie. And we have been told that you may assume Patia eats cookies instantly because they were dealing in minutes. So that's why they have been telling about this. And he will not eat 2 or more cookies near the same bench. At every bench, he will be eating just 1 cookie. And we want to minimize the number of cookies Pete will eat during his walk. In order to do this, you will be you will ask the administration of the summer random stuff to remove exactly one cookie seller from the walkway before Petya starts his walk. And please determine the minimum number of possible number of cookies Petya can eat after removing exactly one cookie seller. Also determine the number of cookie sellers such that if you remove one of them, Petya will eat the minimum number of cookies, minimum possible number of cookies. So what it is asking in the last line is that since as we know that there were some cookie sellers. Let's say there was a cookie seller here, there was a cookie seller here, there was a cookie seller here, there was a cookie seller here. And obviously there was some value of D also. And let's say this is the first place, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. Now what the problem says is that you can remove any of the cookie sellers, like you can remove exactly one. You cannot say that you don't want to remove anyone. And obviously, if you don't remove anyone, you will be having a better answer, like worse answer. Okay, I will take the third test case also. Yeah, we have to remove exactly one cookie seller from here. And the way of finding the cookie seller to remove is not very easy to directly see. So we already we try to figure out the problem from the easy to hard approaches. And you can see that if what if I try to say, let's look what will happen if I remove this cookie seller. Then you will check for the next cookie seller that what happens if I try to remove this one. What happens if I try to remove this cookie seller? What happens if I try to remove this cookie seller? We will try to think about the solution in this approach. So try to figure it out. What will happen if I remove this cookie seller on the place 5? Obviously, the cookie, the way he was eating the cookies till this point will still remain the same. The way he was eating cookies from this point onwards will again remain the same. The only change will be in this region. So we will try to remove all the cookie sellers one by one. Yes, I will see. Like I won't actually remove it. I will just look at what will happen if I remove this. So what will happen if I remove this cookie seller is that this part is still going to remain the same. This part is still going to remain the same. The only difference will be in this part from here to here. And actually for this problem, let's say if D was equal to 3, it will actually even now remain the same. Let's take D equal to 4. So in that case, you will see a difference. So what will happen if I remove it? Earlier, when I didn't remove it, it was present here. So in this region, it was just eating one cookie, that too at this point. But if I remove it, can we take some test cases for given example? Yeah, I will take some test cases also. But right now we are willing to visualize about the stuff which we have to do. So if we are removing this guy, so we save this cookie and we will just add up the number of cookies this Petya guy will eat when he goes from here to here. Right? Like everything before the last cookie seller and everything after the next cookie seller will still remain the same. The only difference will be in this range. So can I say that I can just store up this part? Like for this part about the answer till here, I can just store it. I can just store it inside any variable. Let's say I store it inside a variable like a vector of integers with name pre, which will tell me the number of cookies he will eat here. I can store it inside suf about the part he will eat here. Right. Correct equal to 4. He can survive 4 minutes without cooking. Yeah. He will not eat any cookie for 4 minutes. So now let me take an example. Let's take the third example. Someone said for third 10, 4, 9. So n equal to 10, m equal to 4, and D equal to 9. Yeah, D is equal to 9 and 2, 4, 8, 9, 10. Yeah, 2, 8, 9, 10. Okay, 2, 8, 9, 10. 2, 8, 9, 10. Here are the cookie stalls, like the cookie sellers are present here. So she will eat cookie at first place. Yeah. So first of all, we will eat the cookie at the first place when she comes at the first place. So we will try. So we will just break out the problem into some parts. We will keep track of how many cookies he or she is going to eat till here. Like when he reaches till here, the number of cookies he will eat till this point, the number of cookies he will eat till this point, the number of cookies he will eat till this point. In a prefix sum array, we will store this inside a prefix sum array. How did we get the intuition about the prefix sum array? We got the intuition because here we saw that for every cookie seller, if we remove it, we need some information. The information that what was the number of cookies he would have already eaten till the last stall, the number of cookies he would eat after the next stall. So either you can like do it without storing this inside a vector, or you can just store a vector for your own convenience.
So, sir, basically, you are saying that at each index where the vendor is present, till there you are storing how many cookies he has ate.
Yes, exactly.
Okay.
So for the first point till 2, what will happen? He will eat one cookie when he reaches this point, and he would have already eaten one cookie when he was at the first place. So the number of cookies is 2 for this place. For 8, since the value of D is 9, actually this is not very good test case. Okay, let's do this since it is simple. So from 2 to 8, there are actually 5 bunches in between. Like it is 3, 4, 5, 6, 7, which is just 5. And he can survive till like 9 benches, so there is no problem here. Now the difference is here 1 and 1. So when he reaches till this point, to the test case with to the first test case with 35 and 8. Okay, let's see. For now, let's see that till this bench, he will eat just 2 cookies. First at the 1 and the next at the 2. For 8, he will eat 3 cookies because he will eat a cookie when he reaches 8. For 9, the cookies will be 4, and for 10, the cookies will be 5. And we will do the same thing in the suffix side. So the total number of benches were 10. When he reaches to this point, he will like this will be the first cookie he eat. So it is 1. Like this is the pre. And now we are finding for the suffix also. When he reaches to this bench 9, it will be 2. When he reaches to this bench, it will be 3. And when he reaches to this bench, like this distance of 4, so was 5. So he will not eat any cookie, and it will be just 4 here for the suffix.
Can you repeat the prefix part once again?
For the prefix part, it was like when he reaches to this bench, how many cookies will he eat? One of the cookies will be eaten at the bench 1, and the next cookie will be eaten at the bench 2. Then for the next bench, like when he comes to this 8 bench, he will have like he would have eaten just the number of cookies he had already eaten till here, and the number of cookies he would have eaten to cover this part. For calculating this, we can just say that the number of cookies he ate till here less the number of cookies he ate while covering this part, and the same here. So we can form a relation that pre of I is equal to pre of I minus 1 plus let's create a function with name find, in which I will pass on 2 parameters. Let's say since the problem said that we will be storing. Okay, so let me use the variable a here, the variable a which will be denoting the location of the vendors. So I will be just saying that a of I minus 1, a of I, and the value of d. I will pass on these three things inside a function, and it will return me the number of cookies he will eat to cover this part from here, which is a of I minus 1 till a of I. And you don't really need to worry about how will it do it. We will come up to this part later on. There's no need for way tonight because she can survive 9 minutes. He's not eating the cookie because of moving from 8 to 9. It is just added one because he will eat a cookie when he reaches here at the ninth bench. And in the similar way, I can find for the suffix that suff of I is gonna be equal to suff of I plus 1 plus find of a of I and a of I plus 1 and the d. For this find function, you just need to remember this thing, like instead of writing it every time once again that the number of cookies you will eat from 9 to 10. But like I have just created a function with name find in which I will pass on three parameters actually. The third one will be always same, which is d. And the two parameters which will keep changing is the last time he ate the cookie, which is gonna be the last bench, the last bench on the left side, which is 2 here. So like it will be a of I minus 1 while calculating this b, and the current bench. So it is a of I, and you will pass it. So it will tell you the number of cookies you will eat while traveling from a of I minus 1 to a of I. And like this will just make your code quality a little better, and you won't have to write this thing again and again every time. So it is just beneficial. So now we have got the idea about the pre and the surf. Now you can just simply say that let's say what will happen if I remove this 8 thing. The
Hello?
use of find function is that it is just telling me about the number of cookies Patya is going to eat between these 2 points. The 2 points I will just pass on. It is just making my code more modular.
Excuse me,
Or
I have a doubt.
like if you don't like this, if you don't like to create functions for this thing, then you can like avoid writing it and just write up the whole thing again and again everywhere. We will write the code for find function later on, but
Excuse
just like assume that it is going to give you the correct output for now.
Hello, I
Now
have a doubt.
let's okay. So what is it out?
What if he ate another cookie after the last bench? For every D, if he hasn't eaten a cookie, he will eat, right? So what if our last bench where we ate, the distance between that is greater than D to the present bench? Like in between, he will eat one another cookie, right?
Yeah, he will eat some cookies, and I don't want to calculate it again and again everywhere. That is why I am writing a function with name find, in which I will just pass on the like the range in which I want to find the number of cookies he would have eaten, and just believe that this function will give you the correct output.
Okay, thanks.
If you create functions and believe in them, you can make your code more modular, and the code quality will like improve. The chances of making mistakes can decrease drastically by doing things like this. So now let us see what will happen if I remove this vendor, which is at the bench 8. So the index of like let me just quickly write the indices. The index is 1, 1, and 3. So now I can say the pre of 0 will still be required. I would still require the like he will still eat the number of cookies he was eating till here, till this point, which pre of 0 is going to tell me. He will still eat the number of cookies he will eat after the next bench. After the next bench, from that bench onwards, he will still eat all those cookies. But now between these two benches, he is not going to eat any cookie because of this stall. Instead, he will just eat the cookies which he like eats after some interval. And for finding it, for finding the count, I can just call this find function which I created earlier. So this find function is making my life a lot easy. I just need to pass on A0 and A2 and D, and it will tell me the number of cookies it is going to eat in this range. And I can just generalize this for every I. Like here, the I was equal to 1, and for that, I just wrote this code. So I can generalize this code for every I which is inside the range from 1 till n minus 2. Like um, I is less than equal to 1 and greater than, like inside this range. For all these values of I can just generalize a code that it is equal to free of I minus 1 plus stuff of I plus 1 plus find of A of I minus 1, A of I plus 1 and D. So that's how we can find for every I. And for the first and the last I, like for the first and the last I, we can manually calculate it. For manually calculating it, you will just say that we won't have this pre here, like this pre I1 will not be there. And for the last element, this stuff of I plus 1 won't be there. And you would have to just do some pre-calculate like computation on your own. And actually not that. It's very simple for the first and last one. Obviously, someone has written a doubt in the chat. You want to minimize the number of cookies Petya has eaten during the walk. In order to do this, you will ask the administration of the event exactly one cookie from this. Are we doing this in our approach? Yes. In our approach, we said that for every stall, I am just going to check what will happen if I remove it. How many cookies will I require? And the observation was that the number of cookies I require for like all the stalls till the last bench, like till the last stall, all the benches till the last stall will still remain the same. The number of cookies he eat after the next bench will again remain the same. Only difference will be in the current range. And for finding the current range, I have created a find function. So now let us see how does the find function works. Let us say the range is 0, 9, like the start range is 0 and range is 9 and the value of D is 2. So I can say that he has already eaten a like a cookie at 0. The next cookie he will eat is gonna be at 2, then 4, then 6, then 8. Right, at the intervals of 2. So I just need to know about how many benches are there in between this range, which is equal to 9 minus 0 minus 1. This is the number of on, like let's write some generic thing. It is gonna be end minus start minus 1. You can divide this thing by D here. So you will find the number of cookies he is going to eat inside this range. So is the approach clear to you guys? Are you with me? Guys, just write yes if you have understood this. Okay, pretty cool. So you guys have understood this. So let us move to the code part. Okay, let us use a test case. Let us take a good test case which makes some sense. Maybe this one, the second one. Or yeah, I think that we can take up this test case if you want. Fifth, this one, okay. 35, 8. 35, 8 and 6, 8, 12. 6, 8, 12, 20 and 27. 20 and 27. So here you know that the number of benches are 30. So the low range is at 0 and the higher one is at 30 here. Are you using recursion to in find function? No, I'm not using any recursion in find function. In the find function, it is just direct one formula that end minus start minus 1. It is always a better idea to write this kind of things inside a function so that you can freely use it anywhere. But for this kind of thing, if you don't like, if you had to use it at just one or two places, then you can avoid writing the function as well. So how many, like, let's create the pre-function. At first, you will eat a cookie at 1, and the value of d is 8 here. Yeah, I've written it correct. Yeah, so value of 8 is correct. 8 is d is 8. You will eat the first cookie at 1 bench, and after that you will reach till here. So the number of cookies will be just 2 for the first bench. Then for the second bench, it will be 3 because after 6 you ate the cookie directly at 8. Then you will directly eat the cookie at 12. Then after this point, you will eat the next cookie at 20 because in this range there are 7 benches and you will not eat any cookie in this range. So the number of cookies still here is 5. Now the number of cookies still here is just 6. So, like, I don't think that this test case is good. Okay, yeah, it can be good. And after this bench 27, you are not going to eat any cookies. And even if you were going to eat it, so we have nothing to do about it in the pre function. Now, let's create a sub array. So here the number of cookies you will eat after this bench is 0. So we will just eat 1 cookie for this bench. The number of cookies you will eat from this bench onwards is gonna be like 1 cookie at this bench and 1 cookie at this bench, no cookie in between. So 2 here. And again, like there are just 7 benches in between, so we will not eat any cookie in between. So after this, like the number of cookies you will eat after that 12th bench is gonna be just 3. And similarly 4 and 5 here. Now let us check for every bench. So I will be just writing and erasing it here only. Let us use a different pen. So let's say that I'm going to erase this. What if I erase this bench? What will happen? The number of cookies I will require is gonna be equal to this thing. Like after the next bench, I will be eating 4 cookies. And now I just need to find out the number of cookies I will be eating from 1 till the point 7. And where the first cookie will be eaten at 1, and like you can manually handle it by writing some code, something like if this point is pose, so it is going to be something like pose plus d minus 2 by d. You can write a code like this, and please explain this part again. Okay, so I was saying that what if I have to remove this bench, then I will for finding the number of cookies I will eat after this range can be found here. I have pre-calculated it. Now I just need to find the number of cookies I will eat in this range. So for finding it, I can just say that I will eat the first cookie at 1 point, and like you can use up a formula like this. I think that I don't need to explain how to come up with this formula, or you can like have any formula of your choice for this. I came up this one. This is nothing but ceil of the number of blocks you have. So something like the ceil of pose minus 1 by d, which can be written as pose minus 1 plus d minus 1 by d, like this. And that's how I came up to this formula. So let's go ahead. That we will find out the number of cookies required here. So let us just write the number of cookies I required here. I required 4 cookies after the next bench and 1 cookie here. So the answer got 5. Now I went to the next bench. Now I'm trying to remove this bench. So what will happen is that now I'm going to divide the ranges like this. The number of all the cookies I require in this range, which I have calculated in this sub array. all the cookies I eat till here, which I have pre-calculated here. And now I just need to calculate the number of cookies I require in this range. It is gonna be from the range 6 to 12. I can just pass on these variables inside the find function, and it will see that between 6 and 12, there are 5 blocks, and I'm going to eat cookies at the distance of 8. So there will be 0 cookies eaten. And thus my answer will become 2 plus 3, which is again 5, and 2 plus 3 plus 0, which is 5. Since it is already equal to answer, I will just increment the count, since we have to print the count also.
Sir,
And in the similar way, we can like just do for every bench. So what are you saying?
sir, I was saying that as you said that between 6 and 12 there are 5 blocks, and between them I cannot eat any cookies. After that, what is the step?
After this, like
Yes.
I just calculated the number of cookies which I will be eating if I remove this, because I have calculated this, I have calculated this, I have calculated this. So the sum is 5 here. And if you read the problem statement, we have to say, we have to tell the minimum number of cookies we eat, and we have to tell about its count as well. And this part is again like pretty basic, that whenever you get uh, the value of answer changed or basically decremented, you will set the counter to be 1, otherwise you will increment the counter. And
Okay.
again, something you can figure it out yourself. So I will just repeat this for every bench till the last bench. In case of the last bench, the partitions will be something like this. The partition will be something like this. And for this partition, I can pass on the values inside this for inside the find function. And for this, I have already pre-calculated it. So it like made my life easier, and I'm able to find that there are 5 cookies required, and from 20 to 30, it will eat 1 more cookie, so it's gonna be 6 here. Can you please explain how we are calculating the suffix array and we are taking the cookies? And I think that I've explained it multiple times now, just the last time for now, because we have to go wrap up as well. Printing no shops for minimum cookies eaten. It means that we have to print out the number of shops we can remove, and it will give me the same answer. The rating of the problem, I think it should be somewhere around 1400, 1500. Or it can be like it depends upon the submissions, but I think it deserves to be around 1400, 1500. So for the suffix array, again, like the same thing. I said that I want to store the number of cookies I require in this range. I just calculated for suff I myself. Then I said that now I want to calculate this range. So I said it as having 2 parts, this and this. For finding this range, you have already pre-calculated it. And for finding this range, you can just use the find function and just repeat this again and again till you reach the start. Okay, we print the number of, okay, cool, that's good. Whose removal gives us, yeah, we are just trying to find out the shop whose removal gives us the minimum answer. Okay, so shall we go to the coding part? Is this problem, like the approach, clear to you guys? Okay, let's go to the coding part then. So the code I wrote for this problem was a little long. Like I just did some mess up during the contest. Let me remove the unnecessary part. This one. This one is also gonna be removed, and these things could have been written better. And remove this part. This removed thing is not required anywhere. Debugging the answer is neither required. Okay, so now I think that it is fine. Obviously, there is a better way of doing this also. So as we discussed, first of all, we take the inputs, taking the input array as input. Let me write it properly. That the code which I will share at the end of the session will not have any stuff related to template. So don't worry about it. Here I am having the prefix sum and suffix sum, which I've stated, not the real suffix sum and prefix sum, but related to that. And like I just calculated it in the same way. I manually wrote the code for the first part for pre-0, and then for like all the other prefix ranges, I have just used the formula that you will eat all the cookies you ate till the last all plus 1 for the current bench and the number of cookies you will eat between the benches. Okay, so we have not declared function here. Int find, int low, int high, int d, and just say that return something like high minus low minus 1 by d. Can you explain the shop removal part of the output with the explain? Okay. Abhishek, we have done it. Like we took some example here. Like the thing is that we have just not completely dry run it, because if we go for the complete dry run, then it will just that is just unnecessary part, not related to the concept, but just waste of time. I just showed you the flow of how to take up like for the first bench, second bench, third bench, and then like the same stuff for every bench till the last bench. Coming up to the code part. So finding the suffix for the last, we did it manually, that it is gonna be 1 for the current bench and for this range. And then for like all the suffix for the all of the other benches, we calculated it using suf of I plus 1 and the find function. This find function is very useful. If you don't use it, it will still do the job. You can like just write down this thing everywhere, wherever you use the find function. But using the find function can make your life a little easy, because let's say that there was a problem with the logic. I can just make changes here. I don't have to make changes everywhere.
Sir, like if we, for example, let's say we remove this find function and we iterate brute forcefully on every index. Like if there is a stall, we are doing +1, and at like we are seeing that at every d benches away, if there is a stall or not. So can we do that way also for making this prefix and suffix?
Yes, there can be multiple ways, and I'm showing you like a way which I felt to be the most intuitive, that for every bench, when we want to check if what will happen when we remove it, we saw that I care about the number of bench, like some part is gonna stay constant. It won't change. When we remove this bench, it will just remain the same as it was already. So for that, we did some calculation, which is the constant part. And for finding the number of cookies he will eat between two stalls, this was something which we were required to do multiple times. That's why we just created a function to avoid writing the same thing again and again inside the function,
Okay, sir.
inside the answer. Yeah. And now, like just storing this inside answer, that what will happen if we remove the first bench, then checking what will happen if we remove the last bench. It will be like prefix till the last second bench, and all the cookies we will eat between the last second bench and the end of like the last bench, like the last stall and the last second stall and the last bench. Okay. And then we check that if it is greater than answer, then in that case, change the value of answer. And this again, some more redundant stuff which we can ignore. We can just say int cnt equal to 1 here. And we don't really need to use a map. We can just say that cnt plus plus And here we can say CNT equal to 0. Like obviously there are multiple ways of implementing the same thing. You can implement it in any way you like. I'm just making some quick changes. CNT plus plus and just print out CNT again. And now inside this loop, we are just checking for every bench that what will happen if we remove it. What will happen if we remove it? The sum, like the number of cookies you will eat till the last stall will remain the same. The number of cookies you will eat after the next stall will remain the same. And the number of cookies you will eat between the stalls will remain like can be calculated using this find function. And then you are just comparing it with answer and then printing it. So is it fine till now? Like, did you guys understand the problem? Guys, just write cool inside the chat if you understood it. Cooler, cooler AC क्या क्या आएगा then? And now for the people who have been watching this on YouTube, you can go to the comment section of the video and there you will find a form for the feedback on the pinned comment. You can just go there and give your feedback. So I think that we can close the session now and attend some personal doubts if there are any. So thanks for watching the video.